This is the addition rule for probability. And it has two symbols. It has the union and it has the intersection. The probability of A or B or both, A or B or both. Remember this little hump looking thing, that's intersection. It's both, and this is or, either or, both. That's the addition rule for probability. Before we were using something that looked very much alike like this. The only thing that was different was that it had ends, and now we have the piece. So this was just counting, just counts, but this one finds probability. This is a sample space, a universe of tossing two dice. If you toss two dice, this describes all the ways the die can fall. It could be a 1-1, 1-2, 1-3, all the way to 6-6. There's 36 possible outcomes, 36 possible ways the pair of dice may fall. So let two dice roll, and we would like the probability, find the probability the first is a 2 or the sum equals 6 or 7. This or should remind us that we should be working with this formula. This or and this u are related. You could call this an or formula if you like for probability. So we'll let event A be the first die is a 2, and event B, the sum of a die is 6 or 7. Then this will be the probability of A and probability of B. So you go and count how many fit the description of A, how many fit the description of B, and you put these numbers here. And then this 2 is how many fit the description of A and B. Notice they're all out of 36 possible pairs. So you just need to write the 36 ones. Simplify the numerator, 15 over 36, and then reduce. You always reduce. And the probability would be 5 over 12. The complement rule is very handy because it could make a difficult problem easy. And notice how it looks. This has a prime and this doesn't have a prime. This doesn't have a prime, this does have a prime. The one with a prime and the one without a prime are opposites. They're opposites. This is called the complement rule. If two fair dice are rolled, fair means that they didn't mess around with them. If two fair dice are rolled, find the probability that the sum of the numbers is greater than 3. Probably the sum of the numbers of the pairs is greater than 3. This involves many probabilities because in the 36 pairs, there's many pairs that sum up greater than 3. It would be easier to find the ones that add up to less than or equal to 3. So this rule, the complement rule in action, working with opposites, if you could recognize opposite events, you could use this rule to work it easier. So instead of working with this side of the equation, you work with the easier side of the equation. So taking this problem, continuing, the probability of that the sum of the pairs is greater than 3 can be written as 1 minus the sum of the probability of the sums less than or equal to 3. So instead of finding this probability, which would be hard to find since there's a lot of sums greater than 3, you work with this side. So the sums that are less than or equal to 3. And the reason we don't go below 2 is that that's the smallest sum. 1, 1 would give you a 2. That's the smallest sum you could get. And then the next one would be a sum of 3. So go and count. How many add up to 2? Well, 1 out of the 36. How many add up to 3? Well, 2 out of the 36. Then you add these two and you get a 1 over 12. Then 1 minus 1 over 12 will give you the probability the sum is greater than 3. So finally, when you simplify the sum, the probability of the sum being greater than 3 would be 11 over 12.